Now that we know how many solutions a linear equation can have, let's start talking about how to actually find those solutions. If I have an equation like this, 9 equals m plus 4, what that means is m is some unknown number, and what I know is if I add 4 to it, I'm going to get 9. Let's just draw a picture of scales that are balanced. I have 9 items of the same weight on the left side, which would be right here. Equals sign represents the middle of the scale. And then on the right side of the scale, I have some box containing an unknown number of these items, and I also have 4 of those items. The question is, how many of those items are in the box? Well, to answer this question, all I have to do is rearrange this scale so that the box is on one side alone, and I see how many of the items are on the other side that make it balance. Okay? How am I going to make it balance? Like I said, I need to get the box alone on one side. If I take one of these items off, it's going to tip the scale, unless I also take one off on the other side. So I have to take one off on both sides. So if I'm going to take these 4 off to keep the scale balanced, I have to take 4 off on this side. The way we show that algebraically is we're taking away 4. That means subtract 4 on each side of the equation, the left side of the equal sign and the right side of the equal sign. And then do the math. 9 minus 4 equals 5. So our new left-hand side is 5. And the right-hand side is going to be m plus 4 minus 4. Well, if I add 4 and I take away 4, I just end up where I started with, m. And that's what this picture shows. It shows the box, the unknown, on the right side. And on the left side, I have 1, 2, 3, 4, 5 items, which is the same thing the equation says. So this illustrates that I can solve the equation by getting the variable alone on one side. And I can do that, in this case, by subtracting 4 from both sides of the equation. And in general, we can add or subtract the same number to both sides of the equation, and we will get an equivalent equation. This equation is equivalent to this one. And so we see that the solution of our original equation must be m equals 5. Okay? Let's see another example. Two y equals y plus 3. In this case, I've got 2 of my boxes containing an unknown amount on this side of the scale. And on the right side, I have 1 of the box containing an unknown number. And then I also have 3 of those. How am I going to figure out how many are in each box now? Well, just like I took away the same number of items from each side of the scale, I can take away the same number of boxes from each side of the scale. So if I take 1 box away from each side of the scale, it should remain balanced, because each box contains the same number of items. And so 1 box balances with 3 items. So the unknown number must be 3. To see that algebraically, what did we do? we took one of the unknowns away from each side. Y is our unknown. We take one away from each side. 2y minus 1y is 1y, or just y. Y plus 3 minus y, the y minus y is going to be 0. 0 plus 3 will give us 3. So we see the solution is y equals 3. A third example, t minus 1 equals 6. In the previous two examples, we were able to solve by subtracting the same amount from each side of the equation. We can do the same thing here by adding the same amount. You see, we want to get our unknown by itself. If we have our unknown and we've taken one away, that is like we've taken one item out of the box. So what we need to do is replace that item back in the box. So we add 1. So we add 1 to the other side as well. And we get t minus 1 plus 1 simply comes out to t. 6 plus 1 is 7. Now let's take the equation that we've been seeing all along, 3 times x equals 6. And let's see what that looks like using this idea of a scale. We've got 3 of our unknowns that all contain the same number. And on the other side of the scale, it balances with 6 of the item. In this case, we're not going to be able to get one of the unknowns by itself on one side of the scale. However, we can see, as long as we've only got the boxes of unknown amount on one side, and we've only got the items on the other side, we can see I have 1, 2, 3 of these boxes here. So if I rearrange these into equal groups, 1, 2, 3, then each group must contain 2 items, which means each box must contain 2 items. To show that algebraically, what have we done? We've taken the 6 on the right side and divided it into 3 groups. In other words, divide by 3. We've divided these into 3 groups as well. Each group consists of 1 box. So we're dividing by 3 on each side of the equation. And the reason we know to do that is because we have 3 of these unknowns. So 3 is the number we must divide by. All right, 3 divided by 3 is 1. So we have 1 times x, or x. 6 divided by 3 is 2. And there are 2 items in each box, as we said before. The solution is x equals 2. What if we have a similar equation, but the numbers don't quite work out right? That is to say, they don't work out to whole numbers. Well, if we have 3x equals 7, looking back up at this example, that's like we have an extra one left over. So in order for each box to have the same amount in it, we've got to split this into 3 parts and put one of those parts in each box. Okay, so each of those parts is 1/3. So the answer for how many are in each box should be 2 and 1/3. Let's look at it. We already discussed the fact that if we have 3 times x, we're going to want to divide by 3. Whatever number we're multiplying by x is the number we'll divide by on both sides of the equation. So here we get x, just as in the previous example. Here we'll get 7 divided by 3, which is 7/3. Not a whole number, but that's okay. We don't always get whole number answers in mathematics. And we said that it had to be equal to 2 1/3. Well, if you convert this into a mixed number, 3 goes into 7 2 times with 1 left over. So this is, in fact, equal to 2 1/3. We can also have equations in which we have both multiplication, or a division, and an addition or a subtraction happening on the variable side. See, in this one, x is being multiplied by 2, but we're also subtracting 6. So how are we going to figure this out? Well, one more time, let's look at this scale example. What's on the left of the equals sign is 2 of the unknowns, and -6, meaning we have taken 6 away. I will demonstrate that we are taking them away by putting them in a different color. And over here, we have 4 of the items. So what are we going to do? Well, based on previous examples, since we're multiplying by 2 and subtracting 6, it's reasonable that we're going to want to divide by 2 and add 6. The question is, which one do we do first? And we can answer that by thinking about this scale. I'm not going to be able to do what I did before, where I put the ones on the right side into groups, until I only have unknowns on this side. So I've got to get rid of the things that aren't unknowns. Okay? So these 6 green things represent taking away 6, so I have to add 6 to this side to balance that out, which means I have to add 6 to this side to keep the balance. And so to avoid confusion, I'll erase this. Now we have 2 unknowns on the left, and on the right we have 10 items. So what we've just done is we added 6 to the left and right sides of the equation to get 2x equals 10. Now we can do what we did before, where we have 2 unknowns, so we divide the other side into 2 equal groups. Well, if there are 10 of them, then each group must have 5 items. Algebraically, what that means is we're dividing by 2 on each side of the equation. 2 divided by 2 is 1. 10 divided by 2 is 5. We find that the unknown amount must be 5. And we can double check that if we substitute that 5 back into our original equation where x is. We can find out whether this is true or not. 2 times 5 minus 6, what does that come out to? 2 times 5 is 10, because we do multiplication first by order of operations. 10 minus 6 is 4. So we get 4 on the left-hand side of the equation, and that's equal to the 4 that's on the right-hand side of the equation. Okay? The 2 sides are equal to each other. Therefore, the value x equals 5 makes this equation true, so it's a solution of the equation.